In this video, we'll learn about how to solve inequalities. The basic idea is that we can do many of the same things that we do when we solve equations when we're solving inequalities. For example, if we had the inequality x minus 5 is greater than 8, then if this were an equation, we'd think to ourselves that what we should probably do is add 5 to both sides. That way we isolate x and we solve our equation. But this isn't an equation, it's an inequality. So why does that work here? Well, let's think about it. If we know that x minus 5 is greater than 8, then what that tells us is that on our number line, 8 is to the left of x minus 5. And we don't know what x is, so we don't exactly know where x minus 5 is. But what we know is that if we add 5 to 8, that moves 8 to the right, 5 spaces. And so we end up here at 8 plus 5. And if we add 5 to x minus 5, that moves x minus 5 to the right, 5 spaces. And we end up here at x minus 5 plus 5. But since both of those numbers move to the right the same amount of space, the relationship is still the same. 8 was less than x minus 5, so 8 plus 5 is less than x minus 5 plus 5. And so going back up to our inequality work at the top here, the minus 5 and the plus 5 cancel, and we get that x is greater than 8 plus 5, which is 13. And that would be the solution to our inequality, that x is greater than 13. Remember that the solution to an inequality is going to be an interval, whereas the solution to an equation is usually a number. So a little bit different there. Another way that we could describe our answer, instead of using the inequality notation, is we could use interval notation, which, if you recall, the inequality x greater than 13 looks like the interval from 13 to infinity. So this would be another perfectly valid answer to our question. So you should pay attention to the instructions in the problem that you're given. If you're asked to give the answer in interval notation, make sure you do that. Okay, let's do a couple other examples. This time let's try to solve 2x minus 3 is greater than 5. Again, what we'd like to do is add 3 to both sides. And as we discussed before, the relationship is going to stay the same, so we end up with 2x is greater than 8. But now what we'd like to do is divide both sides by 2. So does that change the direction of the inequality? Well, what we'll see is that if you multiply or divide both sides of an inequality by a positive number, then everything stays the same. But if you multiply both sides of an inequality by a negative number, then you have to change the direction of the inequality. Let's think about why that is. Let's start with a simple inequality, something like 5 is greater than 3. What would happen if we multiplied both sides of that inequality by a negative number? Let's say negative 2. So multiply by negative 2 on the left, and multiply by negative 2 on the right. Well, on the left, 2 times negative 5 is negative 10, and on the right, 3 times negative 2 is negative 6. Now, sometimes negative numbers can be tricky here, but negative 10 is further to the left than negative 6. Think about here's 0. So negative 6 is actually greater than negative 10. So that might be a little bit of a surprise, that the direction of our inequality changes when we multiply by that negative number. So the rule of thumb that you always want to remember is that when you multiply or divide both sides of an inequality by a negative number, the direction of the inequality has to get reversed. But if you multiply both sides by a positive number, or divide both sides by a positive number, then the inequality stays in the same direction. So let's go back to our previous problem. Our previous problem was 2x minus 3 is greater than 5. And the first thing that we did was we added 3 to both sides. That was no problem. The minus 3 and the plus 3 on the left cancel out. And we end up with 2x greater than 8. And we were worried about what would happen if we divided both sides by 2, but now we hopefully understand that dividing both sides by 2 here isn't going to cause us any problems. The 2's on the left divide out. We end up with x, and 8 divided by 2 is 4, and since we divided both sides by a positive number, our answer is x greater than 4. In this example, we have 4 minus 3x less than or equal to 19. So our first step might be to subtract 4 from both sides. That gives us negative 3x on the left, as the 4 and the minus 4 on the left-hand side cancel out. And 19 minus 4 is 15, so we have negative 3x less than or equal to 15. So did we divide both sides by negative 3? to get x by itself. On the left-hand side, those negative 3's divide out, and I get x. 15 divided by negative 3 is negative 5, and since we divided both sides by a negative number, the inequality changes direction. So make sure that you realize that when we divide both sides by a negative number, we have to change the direction of the inequality. So this inequality right here is greater than or equal to because we divided both sides by this number, negative 3. But once we realize that, we see that we have our final answer, x greater than or equal to negative 5. Something else that we'll sometimes have to deal with are compound inequalities. So in this example, we've got 4 less than 2x minus 1 less than 9. And so how do we solve this? How do we get x by itself? Well, what we can think to ourselves is that we've really got two inequalities here. We have an inequality that looks like 4 is less than 2x minus 1. That's one of our inequalities. And we've got another inequality that looks like 2x minus 1 is less than 9. What would we do to solve those inequalities? Well, in both cases, our first step would be to add 1 to both sides. We'd add 1 to 2x minus 1, and add 1 to 4, and we'd add 1 to 2x minus 1, and we'd add 1 to 9. So what we can do is take this compound inequality, 4 less than 2x minus 1 less than 9, and simply add 1 to all three pieces. Add 1 to 4, add 1 to the 2x minus 1, and add 1 to 9. In a way, what we're doing is solving both of these inequalities simultaneously. 4 plus 1 is 5, minus 1 and 1 cancel, so we get 2x in the middle, and 9 plus 1 is 10. Now we're going to divide everything by 2. 5 divided by 2 is 2.5. I'll just write that as 2.5. In the middle, the 2's divide out, so we just get x, and then 10 divided by 2 is 5. That is our answer. So with compound inequalities, just make sure that you solve them like you would regular inequalities, but keep in mind that we do something to all three numbers, not just to the number on the left and the number on the right.